Hello again everyone, welcome back to ptet.chemistry channel. So in this tutorial video, I'll be going through a practical session. This is an iodine thiosulfate, and iodine being I2 molecule and thiosulfate being Na2S2O3, that's sodium thiosulfate. So there are a couple of questions that have similar kind of idea. I'm just going to show you one particular question. I've got a printed paper here, although I'm not going to write on the paper. So as you can see, you have got a situation where you've got a chlorine reacting with Ki, giving you the iodine. And our actual titration is the second one, which is sodium thiosulfate, Na2S2O3, plus the I2. The I2 get reduced to I minus, and then we have our thiosulfate going to the S4O6 to minus. Not that the theory matters, but you do need the mole ratio and the balance equation to do your calculations later on. So what we have there is Q is sodium thiosulfate and P is your iodine solution. So iodine being reasonably soluble, not entirely soluble, is used as an antiseptic in hospitals and clinics. So when you get a wound, an open wound, so you know they will put like some sort of yellow or brown solution and stain your skin with it. And what that does is that acts as an antiseptic, and there is actually iodine solution which is brown in color. So being a usual titration, I don't know what happened with the last person who used my apparatus, so I will rinse with distilled water, but whatever you do, you always have to rinse it with the solution that you are going to fill it in eventually before you start your titration, okay? So I'm just going to rinse my pipette. So as I'm doing rinsing, I want the water, the distilled water, to actually roll around the side, and then I try it out from the very top end there. So my sink is over there, hence I am, I want to show you half my body here. So yeah, okay. So I'm just going to let this go this way around. Okay, so now I'm just going to quickly rinse my burette. So by closing the tab at the bottom so that they don't leak, I'm going to roll it around. But remember to always open the tap to allow a bit of distilled water to run through for your washing. And remember, you gotta wash your burette with the solution that you're going to fill it in later on as well. So that's it really on the initial rinsing part. But we know that P, being the iodine, is going to go into the pipette. And Q, which is our thiosulfate, Na2S2O3, sodium thiosulfate, Na plus ions, and S2O3, 2 minus ions. So it's a 2 minus charge ion. I'm just going to quickly rinse my burette before I forget it. So put a little bit in there for rinsing, maybe just a little bit more. So you don't need to fill up the whole burette. So roughly around that much, or that much should be alright. Make sure you open the tap so that this bit is rinsed with the solution that you're going to fill it in as well. Before I do that, maybe I'll just roll it around so that I am thoroughly rinsing my burette. Oops, I just remember I haven't opened the tab at the bottom yet and I ran out of my solution. So open the tab at the bottom. So the bottom is now rinsed with the solution. Throw it out from the top. Open the tab again to remove the washings into the sink. Okay, so now that it's almost dry, but we know that this is the sodium thiosulfate already, so we are reasonably okay. I'm just going to quickly, fill out my burette. Oops. Avoid filling it in on the floor, because you might make the same mistake as me. Okay, so what we need to do is, I need to open the tap so that the burette with the solution that I'm filling in right now will fill up the bottom bit as well. So that much is filled already. So I can just put this up here. Okay, so just give me a minute. I just need to go grab a towel. So I made a bit of a mess. My burette is a bit wet at the moment, so I do not want it to, affect my reading or whatever later on. So I'll leave this be for the time being. I have my conical flask, so I just need to rinse it with a little bit of distilled water. By right, you can wash it with tap water and then just rinse it with distilled water entirely okay. It's okay to have water left over in the conical flask, because whatever you pipette out is going to be an exact amount that's going to go into the conical flask. So it doesn't matter if your conical flask is not dry or it's got some water in it, because it will not affect the mole of what you pipette into the conical flask, and therefore it should not affect what you have from your burette titer. So I haven't rinsed my pipette with the iodine yet. So this is a pipette and this is a pipette filler. So what we're going to do really is I'm just going to suck out a little bit of this. So as I suck out a little bit of this, you can see it is brown in solution. I don't need a lot of it, but I just need to do rinsing. So I'm just swirling it around. Gotta be careful, I don't want to stain my cloth. Take out the pipette filler and then rinse it like that, and you should be alright. So with a little bit of it left in the pipette, it's alright, because we're gonna do a pipette suction anyway. So I think the problem is the brown solution is really staining. I don't want it to stain my shirt at all. I should really be careful with this. So I'm ready to suck out 25 cm cube. So this is a 25 mil, 25 cm cube. It's quite brown in color. The instruction with the use of iodine never ever tell you to read from above the meniscus. So we should read below the meniscus. You should be able to read below the meniscus. So this is just above the line. So what I'm going to do is I'm just going to remove a little bit of it. I think that's just alright. Let me just bring a white towel next to you. Hope you can see the line there. There's like a red line. We are reading below the meniscus because the questions in this kind of titration, they never ever tell you to read above the meniscus. It's not a KMNO4. This is a starch indicator for iodine thiosulfate experiment. You read below the meniscus even for this pipette reading when we pipette out the iodine, which is brown in solution. It's 25 cm there. Press the button E to eject it into the conical flask. As I mentioned, your conical flask can be a little bit wet with some water. It's alright, because whatever you prepare out is an exact mole, exact volume, therefore exact mole of the iodine solution. So it doesn't really matter that you add a bit of water. Take out your pipette filler. This thing is brown in solution, so you see a little bit of droplet at the end there. You're not going to get everything out, but tapping very gently. 1, 2, 3, 4, 5, 6, 7. You're still going to be left with like one drop at the end. That is taken into account by the level of accuracy of the apparatus. As you could see them, it says plus minus something. That is alright. So what I'm going to do now is I will suck out the second portion of my 25 cm cube so that I can do my first rough titration and the second exact titration here. So just very quickly, that is 25, oops, no, just very quickly. So avoid parallax error, eye on the eye level as you're reading it. Okay, so that is 25, oops, better get it focused. Not too sure if that's well focused. So right below the meniscus, there's 25 cm cube there. So put it in the conical flask and start pressing E, eject. Let gravity does its job. Okay, let gravity does its job. And you should be alright. So just down to the last couple of drops. 1, 2, 3, 4, 5, 6, 7. You will see I've only prepared 2 conical flasks. That's because I'm going to do one rough titration so that I know roughly where I will stop. And I will do at least 2 exact titrations. But I only have 2 conical flasks, so I'll have to wash out one of my conical flasks, and then I'll have to redo it in one of the washed conical flasks. Okay, so let's get started. My initial reading on the burette is to 1 decimal place. Reading below the meniscus, there's 1.6 cm cube. Just to convince you, there's 1.6 cm cube. You don't necessarily have to start from 0.0. You can start from anywhere, but of course your teacher might advise you that you might want to start from a number that's easy to count. I have my calculator. I'm an experienced chemist. I don't care where I start because I roughly know where to count it. So that one again is 1. This is a bit tricky. It's now 1.5 cm cube. Maybe it's 1.5 cm cube then. Okay, but this being my first titration, there is my first titration. Rough titration shouldn't matter that much. So 1.5 cm cube. In a titration, you will have a table like this where you have final volume, initial volume. Where we start, we're going to fill in the initial volume. Do not fill in the incorrect bit. Final reading or final volume is basically where you stop. So it's the final minus the initial reading that give you the volume of the title. Everything, the burette reading has to be to 1 decimal place for IGCSE, GCSE or all level, the 14 to 16 years old curriculum. Okay. So what I'm going to do is I'm just going to write on a piece of blank paper. So what I have is initial reading or initial volume, and then my initial volume just now was 1.5. My final volume, well, yet to be seen actually. So I have something like this, but of course in a real exam you will have the actual question sheet to fill it in. Without further ado, let's get started on the practical. So I've got a white tile at the bottom here. Let me just move my camera around. Okay, I've got a white tile here so that I could see my color change better. I'm doing a rough titration, and they did say that we want to add a starch indicator. So starch is this kind of like cloudy, colorless solution. In the presence of iodine, it will turn the solution blue-black. That's the test for starch in food, in biology. But what we're going to do is we're going to add starch to this substance and it turns blue-black is because this substance contains iodine. We don't add our iodine straight away, we add it when it gets a bit more diluted. When most of the iodine is almost gone, then it goes almost yellow. This is now brown, okay? So I'm doing a rough titration. I don't really care about where I stop, so I don't slow down at all. I just wait until it gets a bit yellow, then I will add my starch indicator. It's still a bit brown. We must remember to add our indicator because without the indicator, we might not see a very sharp end point. So it's getting a bit lighter now. As you can see, it's not as brown as it, well actually it's still pretty brown actually. So let's add a bit more. So this was the original solution, a lot darker. This is just the iodine on its own. This is the one where I've added a bit of thiosulfate already, so some of the iodine has gone to iodide. I would say this is about the region that I would add in the starch. I mean, it depends on you really, but the moment I add in the starch, you should hopefully see it get blue-black. You don't need to add a lot of starch, because just a little bit of starch will give you the blue-black coloration. So it's kind of like dark coloration. Of course, the more you add, the darker it becomes. If I add just a bit more starch, as you know, indicator does not get involved in the reaction. They simply give you a color change here. So even though this is already brown, it gets a bit difficult to tell the end point without the use of the starch indicator. So we should expect it to go, well, colorless, because when all the iodine is gone, there's no iodine, then starch with no iodine would just be colorless. Alright, so let's see what happened here. So my hand on the tab, I don't care where I stop. I open it full speed, and then when it turns colorless, then I stop. Okay, this by far is not an accurate titration because I did not do it drop by drop. If you want accurate, you have to do it drop by drop. I was kind of like going all the way, and then as soon as it changed, then I stopped. This is called rough titration. I'm ready to read my reading now. This one is 21.9 cm cube. If I just bring my white tile here, 21.9 cm cube. Hopefully you can see that better. Let me just move that out a little bit. So 21.9 cm cube. So reading below the meniscus, 21.9 cm cube. So you got 21, 22, so you're reading downwards. So 21.1, 2, 3, blah, blah, blah. Middle point is 21.5. So you got 21.9 below the meniscus there. So this is my rough titrations. I think 21.9, so what was that? 21.9 final volume minus 1.5 initial volume. I get 20.4. This is my title volume. Something like that. So that's my title volume. So this is my rough titration, right? So I think we're ready to get on with the second titration. So I'm starting from the exact volume where I left off, 21.9. And we know that is acceptable because it was around 20 something plus 21 is still going to be 40 something. I still have enough on my burette. So I can start from 21.9. A lot of teachers, a lot of instructors would probably advise the student to start from an easy number like 0.0 or 10.0 or 5.0. There's no certain advantage to it, it's just make it easier for you to have a same starting point every single time. But experienced chemists will know that it's all about the volume that matters. So I could add my rough title to my initial volume. So my rough title was 20.4. If I'm starting from 21.9, 21.9 plus 20.4, 21.9 plus 20.4, I get 42.3. So this 42.3 is going to be a rough title. So what I want to do is I want to be careful when I am very close to 42.3, maybe around 40. I'll let it go fast until 40, then I'll do drop by drop just to be safe and get an accurate title with one drop. Okay, so let's get started. So 42.3 would be my rough endpoint. So 40 is where I'll stop down, I'll slow down and do it drop by drop. So 40 is around there. But I might want to add my indicator when it changes brown. I don't really need to swirl that much at this point in time because I'll just be wasting my energy. So I just need to let it flow. And then when it's close to, supposed to be 42.3 for the rough title. Rough title means in excess. So I'll just keep on adding until it's pretty close to the end point. Then I'll do it drop by drop. That's the purpose. The purpose of doing a rough titration is so that I know roughly where to stop. As you can see, it is still kind of like yellow with browns. So there's still iodine left in there. So what I'm going to do is I'm going to add my starch indicator. So 2 or 3 drops, and then it goes blue-black. Here now, because I'm right-handed, I am going to swirl with my right, and then I open the tab with my left. I'm very close to the end point. I do not want to close open like that. No sudden movement. Get it drop by drop first. That's the most important thing. Get it drop by drop first. Oops, my bad. Too fast. Okay, that is just right. So I hope you can see the color change there. So that is drop by drop. So my eye doesn't take away from the thing above the white tile. As soon as it changes color, then I stop. I do not care about the volume. I don't read the volume right now. I read the volume at the end point. My left hand doesn't leave the tab. As soon as it changes color, then I will, as soon as it goes, one drop and then colorless, I will stop. That will be my end point. So you need to be very patient at this stage. So just keep on going. So very close now. I think one more drop will do. Just be careful. I shouldn't have stopped. There you go. One drop and it went colorless. Just one extra drop and it went colorless. I shouldn't have stopped just now. I should have let it go all the way drop by drop until it changes, only then when I stop. Okay? Now ready to read the reading of the burette. So there's my endpoint, there's my accurate endpoint. I knew it was accurate because I did it drop by drop. So, oops, I don't want to zoom in. So that is 41.9 cm cube. You should hopefully see that, 41.9 cm cube. Let me just twist it around. So 41 on top there, 41.9 if you read below the meniscus there. Okay, 41.9 cm cube. So what do I have there? 41.9 for my final title, minus 21.9. This is what my calculator showed me, 41.9 minus 21.9. This is what the calculator will show you. If you write this down as 20, you will have made a mistake because your calculator cannot think on your behalf. It's still a burette title. It has to be to 1 decimal place, at least for this 14 to 16 years old, O-level, IGCSE, GCSE curriculum. And if you're doing A-levels, you will have to do this to 2 decimal place. Anyway, let's refill our burette a little bit with this thiosulfate colorless solution. don't need a lot of it, just probably around. So I could fill it up to around 21, 22, and then give or take, just now my exact titer was around 20, so I will have enough anyway, okay? So I'm just going to quickly wash my conical flask, because remember, we can just wash it with this, tap water first. So I'm just going to wash it with tap water, so throw it down the sink. And then I'll quickly rinse it with distilled water. So what happened now is, let's just pipette out what we need. Oops. So doing our second exact titer, which is essential. I think I've got a bit of A inside actually. So you don't want air bubbles inside your pipette reading. So let me just get this right, and then I'll show you where I am. Oh no. I would say that is alright. Nope, that's not alright. But this one is a bit annoying because it keeps giving me some air bubbles. Okay, so there's 25 ml, 25 cm cube there, just below the meniscus. Hope that convinced you. I've got a bit of water left in there, but it's okay. Remember that a little bit of water will not affect the accurate mole of the substance that we prepared out. And if the mole of the stuff that we prepared out is exactly the same going to the conical flask, so it will not change the volume of the things in the burette, so it doesn't change our titer at all with a little bit of distilled water left in the conical flask. Just the last few drops, 1, 2, 3, 4, 5, 6, 7, blah 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 blah. Okay, where do I start? I start from 22.0. So don't have a white towel all the time, but I start from 22.0 cm cube. So give or take 22.0. So my second titer should be my third titer should be the same as the second, because I'm a competent chemist. I'm expecting plus 20. 20 plus that should be 42.0. 42.0 because of the 1 decimal place accuracy of burette. So I need to be careful when I reach 41 and do it drop by drop from there, just to be safe. And don't forget to add your starch indicator at the end. So where's 41? Yeah, 41 is here. So 41 is there. We're just gonna zoom in a little bit. So I don't need to, swirl or anything, because I've done my exact titer. I roughly know where they are now. So 41 is where I will stop, because that is just before the exact endpoint there. So getting close, getting very, very close. Okay, so it is still a bit yellowy, yellow solution, because there's still some iodine left in there. What I'm going to do is I'm just going to add the starch indicator, and here's where I need to be careful and do it drop by drop. So get your drop by drop, really drop by drop. It's going to take practice and time. It will be slow, but you want to be as accurate as possible, so you don't go full speed, you just swirl gently. Doesn't take much, I think. It is slow, very slow actually. So eyes, do not take your eyes off the conical flask. Don't even bother with the reading, because you are doing exact titer, so you can read the reading later on when you reach the end point. And don't take your hands off the tap as well. So one hand on the tap and one hand swirling. You don't need to swirl that strong, but one drop will give you the color change. I think the next drop should give me a color change. So pretty sharp, and then I stop straight away. Okay. So now I'm going to reach my end point. Is 44 41.0, 41.0. So, sorry, no, not 41, 42.0, okay? Am I correct, 42.0? Give or take, actually that's 42.1 to be honest, 42.1. Oops, let me just zoom that out. So, I have lost a bit of accuracy, so that's 41, that's 42. So that should be 42.1. You might read as like 42.2, but I read it as 42.1 cm cubed just now. So that was 42.1 cm cubed. And that is not as exact as we get it to be. That give me 20.1. So what I've gotten is my rough title. My rough title was not drop by drop. It can never be exact. My exact title got to be lesser than the rough title because I did not do this exactly. As you can see, the exact titles, they are pretty accurate to each other. Acceptable margin is plus 0.2 cm cube. This is an error margin. We do not want to have error, 0.2 cm cube difference. We do not want that. We want it to be as exact as possible. In fact, we want zero difference. If we are a competent chemist, we should get them to be as exact as possible. But clearly I'm not very competent, hence I have got a bit of a difference, and we're only human, so we can obviously make mistakes with a little bit of 1 drop or 2 drops, but it should be within the acceptable margin of error, as you would know if you have done enough alternative to practical as well as practical paper. Okay, so that's all from this tutorial video. I hope this practical session has been useful to you. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel, and look around the video descriptions on all the videos on my channel. There should be a document file to the Google document that will allow you to navigate all the videos on my channel as easily as possible. Thank you for watching, and do follow me at ptet.chemistry. That's at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram to get connected. I'll see you in the next tutorial video. Thank you again.